Hey, thanks for being patient. I'm Theresa and I'm a VR game designer who studied psychology as well, and I want to talk to you a little bit today about the new medium of VR. And when we think about VR, we think about the future, right? We think about what's next, but I think to understand some of what we're seeing right now, we need to think about the past. So, just connect that. So I want to take you on a little trip back to the 90s. Cool, it's working, great. So remember GeoCities? Remember blink tags and animated marquees and, scrolling marquees and animated GIFs everywhere? It was pretty cringy. Well, right now I think that VR design and development is kind of having its own GeoCities moment. So a point of a lot of the stuff that we saw was to draw the user's attention to a feature that the developer wanted them to engage with. But this was largely resolved with standardization. So we eventually had things like the login UI on the web always in the upper right-hand corner, and that reduced the need for developers to engage in some of these cheesy attraction techniques. Problem is, right now in VR, we don't have those standards yet, so I'm seeing a lot of similar gimmicky, over-complex designs, including in my own body of work, but we're learning from them. So rewinding back on the web, a lot of the evolution was driven by social features. If you remember things like guest books, those eventually became comments, became Facebook, became Reddit, or those under construction animated tractor GIFs that let you know a web page wasn't completely final yet, those became beta tags. They became move fast and break things. They became that's just how the internet works. Right now in VR, we're developing a similar pool of features that we're going to derive the standards of tomorrow from, and that's going to reduce some of this cluttered mess we're seeing. So where are these new features coming from in VR? And how do we know what's worth polishing and refining? With a lot of software, the point of it is the content. But in games in particular, the UI can be part of the point of it. Having a challenging, quirky, or surprising UI can just be a big part of the fun of games. So in VR, experimenting with UI is being pushed forward quite a bit by the gaming industry and gamers and stuff. So with this natural experimentation, we're seeing a lot of new features. These are games just from one Oculus VR jam. And a lot of these games include features that have never been seen before in VR. On Steam alone, there are over 3,500 different VR games, and that doesn't even include anything on the PlayStation Store or the Oculus Store. So there are a lot of games out there. They're bringing a lot of new features. But why shouldn't they all just be smooth and sleek? Well, I can extrapolate a little bit from my own gaming experience working on VR games. I'd say about 80% of our gamers, our users, are what we call VRgens. They've never tried VR before, which means not only do we have to tutorialize the game, we also have to tutorialize the platform. And this can be especially hard because of that lack of standards. So on an established platform, your player knows that, on Xbox, the A button is action, or the B button is back, or if they're playing on the PC, they know that the space bar is going to fire or jump. They just know that, so you don't have to tutorialize all of that. But in VR, we have none of those standards, so we need extra tutorialization. How do you tutorialize something in a VR game? Well, just like any other game, historically, tutorials have been largely visual. But there's a problem in VR, which is that your users have 360 degrees of visual freedom. They could be looking up, down, left, right, anywhere. You don't necessarily know that they're looking at the visual target of what you're trying to teach them, and that can be a big problem. Now, traditionally with a regular game, you can just move the camera over and make your player look at what you want to teach them. But in VR, we know that if you have a mismatch between what your vestibular system is telling you you're experiencing and what your visual system is telling you you're experiencing, it's going to create motion sickness, and your player's going to be upset and take off their headset. So how can you get a player to look where you want them to look? Well, there are some visual and audio tricks. So in one of our games, Bazaar, this is a flying carpet game, we have this shooting star animation that comes up. I don't know if some of you can see this, but the shooting star comes up in front of you, and it sort of guides your attention in the direction we want you to go in. And, you know, it's pretty cool. It's sort of the first iteration of this was this aurora effect. It was this glittering effect along the player's peripheral vision to try to tempt their vision in a direction we want them to look in. But that sort of only worked in orthogonal directions. So that sort of evolved into this blinking dots, this Vegas effect, where we could draw the player's attention in a direction based on this linear pattern of blinking lights. Now, there's some other tricks you can use to guide your player's attention to the feature that you want them to look at. You can use psychological tricks. If you have an NPC, a non-playable character in your game, looking at a visual target and your player sees them, your player will naturally look to that same visual target. But you have the same sort of problem as in the first place is, what if your player is not looking at that NPC? Well, you can just force the NPC into your player's field of view if you want to, but a lot of times NPCs are bipedal, and if you just scoot a bipedal character in front of your player's gaze, especially if your player is moving their gaze quickly, saccading across and back and forth, it's going to look like an animation bug. It's going to look like skating. So in Bazaar, we ended up creating this sort of genie in a bottle. It's magical, so it can fly in front of you, and players don't perceive that as a bug. It just sort of flies up and pops around, and it's pretty cool. And it helps a bit. And each one of these tricks has value in focusing your player's gaze, but what happens in a playtest is, well, one trick might work for a lot of players. It might not work for all of them, so you go back to the drawing board and maybe you add another trick to sort of coax your player's vision along. And the more and more that you add of these, the more it kind of reminds me of this thing. Eventually you're just here, this noisy mess, just like the 90s of web development, where developers were trying to add animations, these spinning new animations, the spinning hit tickers. Ultimately, all of these things are competing with each other, and it creates a pretty heinous experience. Now, this is not unique to the web. It's not unique to VR. We saw this before, if any of you remember Win95. A lot of different applications had sys-tray privileges, where the developer could include animations, notification badges, etc., down in that sys-tray. ICQ alone made my sys-tray a little bit of a light switch rave. So that was a pretty bad experience. And Microsoft came along and put the kibosh on it, and they said, no more of that. The problem is in VR, we don't have a Microsoft coming along telling us what animations we can play or what sounds we can play. We have to be the bad cop, the designers of our own VR experiences. We have to be the disciplinarians of our own runaway designs, restrained editors, but I don't know about you guys, but if you think about the VR designers that you know, we're not necessarily minimalists. We're tinkerers and idea people. We're experimenters. So what happens with everyone is they start out and they say, oh, I want to make something like Minority Report. It's going to be sleek and smooth. It's going to be like the future. And you do. You can totally make that. It's not that hard. But the problem is that nobody knows how to interact with it. So you add a little flashy effect here, a little sparkle there, and pretty soon we're back to Jesse's skiing page, circa 1995. So you got to be careful, or you're going to end up with more of this. So the web went through its own desperate attention-seeking phase, and if you remember, the quintessential, most cringy feature of all that was the blink tag. You can say the point of this was to draw the user's attention to some text, but let's be real, there were other methods you could use. You could use font weight and layout to draw your user's attention. I think deep down, the reason people really gravitated towards the blink tag was novelty. We had animated cursor trails, tiling animated backgrounds, welcome alerts that popped up, cool text in all of its flaming glory. Developers were just testing the boundaries of what they could get away with a little bit of HTML and JavaScript. And the whole thing was a mess. In VR, we've got a similar thing going on. There's a lot of experiments, a lot of gimmicks and tricks. So in the words of Jeff Goldblum, you were so preoccupied with whether or not you could, you didn't stop to think if you should. And I think that's where we're at in VR. It can be really tempting to take a look at this shiny new toy and think about all of the things you can do with it, all the affordances. And this is where it can get a little bit crazy if you're not careful. Features in VR include 360 degrees of visual freedom. You can look around. A game can take place behind you, in front of you, above you. What can you do with that? Sometimes there's haptics involved, which are little bits that can attach to your hands and vibrate to sort of complement the visual experience and enhance your immersion. Some cool things you can do with that. VR headsets sometimes come with positional tracking, which means you can tell where your player is at in the room. And accelerometers are common to most VR headsets, which means you can tell the yaw, pitch, and roll, how your player's head is oriented in the game world. And you can do a lot of really fun and creative things with this. I admit I'm guilty of this. In Bazaar, we added this sort of monkey, and it would crawl along these laundry lines, and if you got too close, it jumps on your head to steal things, and this is what it looks like. So it really covers each eye with a hand, and you have to shake your head to get this monkey off. And we know that you're shaking your head because we have accelerometer data that tells us that. This is the kind of stuff I live to develop for. It's really stupid, but it's kind of fun. Something a little bit more practical is VR has a big input problem. So when we think of input, we think of keyboards and buttons and mice, but there might be something that you're not thinking of when you think of input, and that's your eyes. But they're a really big component to using keyboards and buttons and mice. If you can't see something because your face is masked literally and figuratively by a VR headset, you're going to have a hard time fumbling for that mouse in front of you. So if you don't have access to your eyes or to seeing outside of the VR headset, what can you do? And something we thought about on our team is thinking about moving someone through a tutorial using accelerometer data. With the accelerometer, we can detect if our player is nodding their head or shaking their head. So we said, nod your head yes if you understand this tutorial, or shake your head no. And it was pretty cool at first, but what we saw with play tests is that a lot of people will have a big swooping nod, or they'll do a little sort of staccato nod. There were even cultural differences of what people behave like when you ask them to nod their head. So it turned out that this giant wide variance of what players do when they're asked to nod their head makes it difficult to capture exactly when they're trying to nod. And it turns out it's a lot easier to just have a button that they can click to progress through the tutorial. Similar with the 360 degrees of visual freedom and the accelerometer, we wanted to take advantage of this new real estate above us and below us. So we put our heads-up display literally heads up in the sky. We had this dendritic glowing structure growing out overhead as you're exploring this procedurally generated labyrinth, and that's your mini-map. So you were literally navigating by the stars. And it wasn't just your mini-map. We also had the inventory in the stars is represented by the constellations. So to grab your crossbow, you simply look to the sky and grab it out. But similar to issues with nodding your head and shaking your head, this really cool idea was unsuccessful in play tests because players are just not used to looking above them to find their UI. And if you think about where you're using UI usually, we've been conditioned our entire lives. When we use a calculator, when we use our microwave, when we use our laptop, our UI is right in front of us. Asking someone to look to the sky it's a tall order. We didn't give up without a fight. We added lots of hints and tutorials and tricks to sell this feature, the shooting star, 3D audio. But on top of the problems with unintuitiveness, we also had an issue where it's just not comfortable for players to necessarily look up to the sky as often as you might need to access your HUD. So in VR gaming design, the ouch factor of whether something is comfortable is a big deal. Now, coming from console and PC game development, I haven't really thought as much about players' comfort. But I would say with VR, at least you want to spend about 50% of your design efforts on mechanics, how fun something is, and keep about 25% towards iterating towards player comfort, and then probably another 25% for jumping through performance hoops, which I will get to more on later. So in a traditional non-VR game, like a PC game, for example, you're funneling your player's input through a mouse, and what that does by mouse clicks is it really flattens that variance of the physiological variance of your players. Your players could be able-bodied, less able-bodied, but lots of times they can click a mouse button. It's not necessarily the same thing in VR, where people have different physical attributes that might influence how they're able to perform in a game. And it's not just about your input, whether you can look to the sky or not. There are also just differences in people's bodies. If you can imagine in VR having an escape room where you have a tall person and a short kid, if you put a key on the counter and there's positional tracking, that tall person might have the key within their line of sight, while the short person might be looking up at the counter and not seeing the key. So thinking about your player's physical variance is going to have to play a role in your design. So if your feature isn't working because it's not intuitive, like looking up at the sky for UI, and you keep throwing tutorials and gimmicks, eventually I think it's time to abandon your feature. And if players are hurting because there's something uncomfortable about it, it's time to abandon your feature. And that can be really tough because you've probably invested a lot in tutorializing it and trying to sell this feature. But you can salvage your ideas. So you don't necessarily need to throw them away wholesale. We ended up having an almanac in the sky, sort of Spelunky style. So if you had encountered something in the game, you can go back and look at what you had encountered in the sky. If it's uncomfortable for you to look up, though, it's not going to impede your progress by not being able to look at this almanac. A big problem, though, is that regardless of your prudence on scaling back on these unsuccessful features, they're still going to pollinate across other games because it's really expensive to develop in VR, and developers are kind of borrowing ideas from each other willy-nilly. There's a really open and sharing community, which usually is a very good thing. VR play testing can be really difficult because there are often limited numbers of headsets available. Maybe they're very expensive. They require beefy PCs to run VR, or if a VR headset isn't even out yet, sometimes getting access to that for your playtesters can be really tough. So we're not getting the benefit of these really large public beta testing that we might get in other kinds of game development. And then this is compounded with the fact that the developers are rushing to be first to market, to be launch titles on new VR headsets like Gear, Vive, Rift, Indexed, Daydream. So what ends up happening is features get copied from one game to another without necessarily getting vetted. I know that the heads-up display in the sky got copied into another game, and also the nodding your head and shaking your head. Things I have since taken out of the games are existing in other games. It's sort of a double-edged sword with this very open and sharing community. One of the other reasons that features are very difficult to playtest in VR is that the playtesting experience itself is very opaque. So usually, if you're playtesting a game with someone, you can see what they're doing, what they're struggling with, and take your notes. But if you're doing something like mobile VR, your player's in a headset, you can't really see where they're at in the game. You might see that they're frustrated, but you don't necessarily know where they're at. So if you're doing any kind of VR development where you're going to do playtests, it is really valuable to invest in dynamic audio early so that you can hear where your player's at and know where people are getting stuck over and over. And this is important because nobody wants to look stupid in VR. I was showing one of our games at South by Southwest, and there was a big long line. People wanted to play, and while you're waiting in line, you can see other players. And what the other players are doing is this kind of motion, because in the game, you're steering with your eyes, and they're on a flying carpet. So one of the players got into their headset, spent a few minutes in there, did the motions, seemed like they're having a good time. When they took off the headset and it was time for me to reset it for the next player, they had never left the starting menu. They hadn't even started playing the game. But maybe they didn't want to look dumb, they didn't want to ask a question. Whatever it was my fault for not having a more intuitive UI, but that was a completely wasted session, and They probably thought the game wasn't that good. So anyway, add that dynamic audio, it's gonna help you out quite a bit. So after lots of play tests, struggles, iteration, tutorialization of these features, it turns out for Bazaar, a better inventory system is in a box or on a menu. And progressing through a tutorial works better by clicking a menu, not by nodding your head. And a map, a mini map, is better as a literal map, not a dendritically glowing path through the stars. Players are already navigating so much novelty in VR, new kinds of input, new games, new visual, new sound. They don't have a huge amount of tolerance for navigating something like navigation as well. So this advice is not necessarily super sexy, cool sounding advice, but at the end of the day, just keep it simple, because if your player is not taking off their headset, that is a win. And it's okay to make mistakes and bad features like this, just like with GeoCities, where there were a lot of bad features. VR is in its adolescent stage, where there is a lot of enthusiasm, not necessarily as much expertise. And this awkward stage is necessary for the growth of this medium, because all of these bad features are going to go into the pool of features that eventually will become polished and refined and become the standards of tomorrow. And standardization is going to exponentially result in cleaner designs and when players are relieved of the burden of platform education. So while it's very tempting to think, what can I do in VR? What are the strengths of VR that I can take advantage of? I think this kind of design reasoning can take you down some really unsuccessful rabbit holes. So instead, I challenge you to think about what problem you're trying to solve, because there are so many of them. So the first time I tried VR, suddenly a giant T-Rex was coming at me, and the world around me was very compelling, and I immediately took a step, and I almost hit a coffee table and almost lost my balance. And with a bunch of wires strapped to my head and some expensive equipment on the line, it was a near miss. But I thought about that moment a lot, and I wanted to come up with some kind of mechanic that would satisfy the player's urge to explore while also telling them that it's okay to plant your feet. And I thought about surfboards and skateboards and snowboards, and that's where the flying carpet came from. The entire design of this game sort of evolved from that one moment, and it's important to take one of these moments and let it inform other design decisions, because in VR there will be a lot of them, trust me. And that is because VR has a lack of abstraction. So the first computer games that we remember, Pong, Minesweeper, they're very abstract. They're circles and they're squares. The game area is simple. But in VR, there's a first-person camera, and this implies a lot. It implies perspective, that there's an up, down, a left, and a right. What does the sky look like? What did the sky look like in Minesweeper? That question doesn't even mean anything. But in VR, your player can look up, which means you have to draw something up there, which means you have to come up with what does the sky look like. And there are going to be many more decisions like this, and we have to resolve them. So we're no longer able to focus only on communicating mechanics. And you were forced into this relative realism through the nature of the medium. And I don't mean an artistic realism, I mean a one-to-one relationship between the player and the game. So if you're in VR and you look into a reflective surface, you're going to expect to see your avatar looking back at you, which means the designer has to design an avatar. You know, if you think about what did the avatar look like in Minesweeper, what did the sky look like, Kurt Johnson, who came up with it, didn't have to design any of those things. But we do, and it can very easily become a juncture for more clutter. So with many variables to design, I think it's really helpful to think back to the design decision that you're trying to solve. For me, it was that flying carpet, resolving the locomotion issue. And think about how does that inform the other decisions. So what does the skyline look like? Well, where would a flying carpet be? Maybe it's in an ancient Ottoman city. And what does the ground look like? Maybe those are the city streets. So if you drive your design through these solution-oriented designs, it can help you clean things up. It can be a challenge to keep things clean. And on top of that, you're operating with some pretty major constraints. So Some of these constraints are going to be around your player's comfort, and some of the constraints are going to be around performance. So constraints around comfort in VR are, we know that there's going to be a lot of issues if you have a mismatch with your vestibular system and your visual system. So you want to avoid panning the camera. You want to avoid curvilinear acceleration. You want to avoid high-frequency texture scrolling through your peripheral vision. Avoid multi-hour duration games. So think about what kind of game can you design that naturally avoids these. So for us, Bazaar, it's a roguelike game, which means it's got a quick, difficulty curve, which means players die pretty quickly, and that's good because it keeps the game durations short, so they don't push against the issues of getting tired of dealing with VR. It's got low-frequency textures. It's got linear acceleration only, and you use your gaze to guide where you steer your carpet, which means you have that match between your vestibular system and your visual system, which is what you want in VR. So the constraints you're dealing with performance are also going to be important for informing your design. In mobile VR, you might be dealing with hundreds of thousands of verts limits rather